Welcome to Math 1314. This is section 2.7. We're investigating some features of the graphs. So, in this first question, let's take a look here. We have two functions. I have f of x is x squared, and I have f of x is x cubed. Well, x squared, the exponent of 2, is an even number. And for x cubed, the 3 is a odd number. It happens that these are sort of the prototypes for functions that share similar features. And that is, if I take the origin here, and I take the right side of the graph and I fold it over the y-axis, it will look exactly like the left-hand side. Now, said another way, what this is saying is that f of the negative side looks exactly the same as f of the positive side. So again, if you take your graph and if you flipped it about the y-axis, just the right side, flip it around, it would match up exactly with that side. Now with x cubed, that's an odd power. Now notice if I flip this around the y-axis, it would look like this piece in blue, but that doesn't look like what we have on the left. But if you take that piece then and flip it down around the x-axis, it would look like that part. So what this is saying is that f of the negative side looks like minus 1 times f of the positive side. So if a function behaves like x squared, we call it an even function. And if it behaves like x cubed, then it's an odd function. So here in question 1, we have this nice graph here. And the question is, if I take this little part that I have in red and if I fold that over the y-axis, if it were even, it would look like that. But ours doesn't. But if you take this piece then and flip it down, it would match up exactly with that part. So therefore, this function is an odd function. All right, what about question 2 here? Let's see. Remember, we're chopping it here at the origin. So picture taking the y-axis. Now take everything on the left, fold it around to the left-hand side, and does it look like the stuff on the left? Let's see. This thing on the right, if I fold it over, let's see, where is it? It's at 3. If I fold it over, yes, it is at minus 3. And all of this branch, if I fold it over, looks exactly like the left. Therefore, this is an even function. In question 3, we see that a function doesn't have to be even or odd. There is a third category, and that is it's a neither. So let's see. If I take this piece and I fold it around, it would look like this piece that's here in red. Well, clearly not even. What about odd? What if I take this piece and I now flip it? Well, let's see. I would be taking this point that would sit there. This piece would flip. But let's see. You might say, well, if you flip this up, doesn't it look like this little piece and this piece might flip down? Well, let's see. Is that true? This one is down at minus 1. So if I flipped it over, it would still be at minus 1. And if I flipped it, it wouldn't go any higher than 1. Therefore, it's not odd. So it's not even, it's not odd, it is a neither. So it is a neither. All right, question 4. We have a piecewise defined function. H has 3 different rules, all depending on where the input is picked from. So let's see, H of 3. All right, so I got to see, where does 3 live here? Is 3 less than minus 1? No. Is 3 in between minus 1 and 5? Yes. So that tells me which rule to use, and that's this rule. So I'm going to use the rule of square the input and add 3. 3 squared plus 3 is 12. And so I continue this for each input. Let's see. Minus 2. Is minus 2 less than minus 1? Yes. So therefore, I'm going to use that very first rule of minus 5x plus 6. So I'm going to fill in minus 2. Minus 5 times minus 2 is a positive 10. 10 and 6 is 16. So you're going to do that for each and every one of these. Let's see, minus 1. Is minus 1 less than itself? No. Is minus 1 greater than or equal to itself? Yes. Therefore, we use the second rule. Minus 1 squared is 1, plus 3 is 4. So again, it's all about looking at the input, seeing which input category are we in. That gives us a rule. Is 5 less than minus 1? No. Is 5 in between minus 1 and 5? No. Is 5 greater than or equal to itself? Yes. So that gives me the third rule. The third rule is a constant function. There are no x's on the right-hand side. So h of anything will be 6. H of 5 is 6. And similarly, the last one, h of 6, that falls into the third category. 6 is greater than or equal to 5. Therefore, h of 6 is 6. All right, in question 5, they're going to give us a function, and then they're going to ask us to chop it. Chop it for particular inputs. So what does x plus 4 look like? Well, that's just a line. Has a positive 1 for the slope, going up, crossing at 4. So here's my line going up, crossing at 4. Now they say chop it only for inputs less than 0. Okay, so here is 0. I'm going to chop it there, and I take everything less than it. That means I have this whole branch. It's an open dot because there's no equal. So let's see, which one is it? No, not that one. No, not that one. Yes, it is that one, and no, not that one. So we're going to graph whatever shape they give us and then chop it out. Let's see, f of x is x plus 3. All right, x plus 3 is a line going up. Slope is 1, crossing at 3. Okay, now where do I chop this big line in red? Well, between minus 3 and 0. So you see here's minus 3. Here's 0. Let's see, minus 3 is an open dot. Okay, open dot there. And plug in 0. 0 is a closed dot. Well, let's see, if you plug in minus 3 plus 3 is 0. That's how I know it's right there. And so I'm using the x's that are in between there. So I get this picture, which matches exactly with this first one. Let's see, question 7. Question 7, when I first saw this, I was thinking, well, I already did this. F of x is x plus 3 looks just like the one we just did. Maybe it's a repeat. Well, let's see. This number 6 was minus 3 less than x less than or equal to 0. Yes, here is the same, very similar, but now the equals is on the minus 3. The open dot is on the 0. So yes, it looks very much like 6, but where the open and closed dots are is reversed. So no, no, yes, it is that one. Let's see, question 8. Now, question 8, 9, and 10, there's a separate video, if you look on the schedule, for physically how you actually make these in Connect Math. Let's see. First off, we have two rules. Absolute value, which is the V-shaped item, and minus x plus 6. That's a line going down, crossing at 6. Okay, got that part. Now, I'm going to chop it. I'm going to chop it at 3 on both of them. So chop it at 3, chop it at 3. This one is an open dot there, and this one, because of the equals, is a closed dot. Now, where is that dot? Well, if I plug in 3, absolute value of 3 is 3. And here, if I plug in 3, minus 3 plus 6 is 3. Let's see, on this graph, I'm using all of this left-hand branch. And here on this part, I'm going to use this stuff. All the stuff that's greater than or equal to 3. So notice this open hole is going to match up exactly with that dot. And so when I put this on the graph, what you see is, here's our little piece that was absolute value. Here is the 0.33 where they exactly lined up. And here's my line going downward. Question 9. Let's see, two branches here. I've got a minus x squared plus 1. That's my basic shape that's flipped over. So it's a parabola flipped over and raised up by 1. So you see this top point here is 1. All right, so got that piece. What about this? 2x minus 2. That's a line. Positive slope going up, crossing here at minus 2. Now, I'm chopping it at 1. Well, let's see. If I plug in 1, what is that? Let's see. We're chopping it at 1. I'm going to have minus 1 squared. Well, 1 squared is 1. Minus 1 plus 1 is 0. Yeah, so I'm just plugging in 1 in for the x, and that's how I know where that dot is. And it's a closed dot. What about here? I'm chopping this one at 1. Let's see, where is that one? Well, let's see. Plug in 1, and then what? 2 times 1 is 2. 2 minus 2 is 0. Hey, they're going to match up. Closed dot, open hole, matching up. So I've got this piece, everything to the left of 1 of the parabola, and I've got this piece of the line, and they're matching up at the dot. Let's see, and there's my graph. Let's see, this was at 1. Here it's crossing here because minus 1 squared is 1. Minus 1 plus 1 is 0. So here's my little parabola flipped over, and here's my line going up, and here's the point where they matched up, and that was at 1, 0. The last function, I have three pieces, but they're all constant functions, perfectly flat. This is a flat function crossing at -2. I got a -1 piece here and a piece that's 1. Okay, so the red is the originals. Now, where am I chopping this? Let's see, the first one, -4 to -1. -4 to -1. Close dot on the -4 because of the equals, open dot there. The next one, -1 to 0. -1 to 0. 0 is a open dot. Okay, got that little piece. So we have a stair step. It's at -2, then jumps up to -1, and finally on the last part, 0 to 3. So here's 0. Close dot here because of the equals and the 3. So now it's jumped up to 1. So what does this look like? Well, there's my little stair step. It's at -2, jumps to -1, jumps up to 1. It's between -4 and -1, -1 and 0, and then 0 and 3. So lots of good stuff with graphing in this particular section.